Today we're going to be learning about solving absolute value inequalities. Our objectives is that we will be able to solve absolute value inequalities, we will be able to graph the solutions on a number line, and we will be able to model real-world situations with absolute value inequalities. So let's think about what absolute value equations and inequalities mean. So if we want to be 3 units away from 0, that means the absolute value of x is equal to 3. So that could be for positive 3, or that could be for negative 3. If we want to be less than 3 units away from 0, the absolute value of x would have to be less than 3, which means it's anything between negative 3 and 0, and between 0 and positive 3. It also could be anything in between those. It doesn't have to be a whole number. If I want to be greater than 3 units away from 0, my absolute value would have to be greater than 3. And if I'm looking at the graph, that would be anything outside of 3. So if you notice, when it was less than, they were all stuck together in the middle. When it was greater, they split up and went to the outside. So we're going to use that idea in a little bit when we graph our solutions. So we're going to solve each absolute value inequality and then graph our solutions on the number line. Just a little reminder, here's our steps from last class about how to solve an absolute value equation. The same steps are going to apply to the absolute value inequalities. So we're going to isolate the absolute value, write our 2 equations, in this case inequalities. We're going to solve each of them, we're going to check our solutions, and then we're going to graph on the number line. So in example number 1, our absolute value is already alone. So we're going to split it up into our 2 equations. We're going to have our positive equation and our negative equation. So 2x plus 7 is less than 11, and negative 2x plus 7 is less than 11. I'm just going to draw a little. So now I'm going to solve these. I'm going to subtract 7 on both sides. Divide both sides by 2, and I get that x is less than 4. Sorry, less than 2. On my negative equation, I'm going to distribute the negative. So I would get negative 2x minus 7 is less than 11. Add 7 to both sides. And I'm going to divide both sides by negative 2. And thinking back, if you divide by a negative, the inequality is going to switch directions. So because it was less than, it's going to turn into a greater than. So x is greater than 9. Sorry, negative 9. Can something be bigger than negative 9 and less than 2? Well, yeah, because negative 9 is less than 2, and 2 is greater than negative 9. The way we think of this that can help you remember, our original inequality before we split up was less than. You can think of that as less than And means they go together. So because these, basically what we're saying is every number in between -9 and 2, our final answer is going to be -9 is less than x, which is less than 2. So we start with our lower value. We're going to use less thans. Our x goes in the middle, and then our higher value. So when we graph this, I'm going to say 0 is about here, so 2 is about here, -9 would be way down here. Since they're just less than symbols, I'm going to use open circles, and then I'm going to fill in everything in between. In number 2, we need to get the absolute value by itself before we can split up to our two equations. So I'm going to divide by -5. And again, because I'm dividing by a negative, that's going to flip the inequality, so this is going to become greater than. So the absolute value of 3x minus 2 is greater than or equal to 8. Now I can split up into my two equations. 3x minus 2 is greater than or equal to 8. And negative 3x minus 2 is greater than or equal to 8. So I'm going to add 2. Divide by 3. And I get that x is greater than or equal to 10/3. In example number 2, I could distribute the negative like I did in number 1, but we also have dividing by -1 as an option. But remember, if we divide by a negative, we flip the inequality. So 3x minus 2 is less than or equal to -8. And I'm going to add 2. 3x is less than or equal to -6. Divide by 3. X is less than -2. Now, something cannot be bigger than a positive and smaller than a negative at the same time. The hint here is this said greater, or you can think of it as greater. So my inequality is going to be x is less than or equal, or sorry, greater than or equal to positive 10/3, or x is less than or equal to -2. When I graph that, put 0 about here, -2 would be about here, 1, 2, 3, 10/3 is a little bit more than 3, it'll be right there. It'll be closed circles this time because these are greater than or equal to, so because it had the or equal to, we're going to fill in the line. We want greater than 10/3, so that's this way, and less than -2 would be this way. So greater, think of it like the oars of the boat, it's going opposite directions on each side. All right, so in example 3 and example 4, they look almost identical. Here we have the absolute value of -6 being less than -7. Well, we know when we take the absolute value of something, it's going to come out to be positive. -7 is a negative. Can a positive be less than a negative? No, that can never happen. So there is no solution. So again, you would write no solution. You can do the curly brackets with nothing inside, or the 0 with the slash through it. And here's our number line. We're just going to mark that 0's there, but we're not going to graph anything on the number line because there is no solution. Example number 4 is a little bit different because this time we're dealing with a greater than symbol. So we know the absolute value is going to come out to be a positive number. -7 is a negative number. When are positives greater than a negative? Well, always. That's always true. Therefore, This solution is all real numbers. You can write it out like that, or you can do the special R that means real numbers inside curly brackets. As far as our graph goes, since it's all real numbers, we fill in everything. So now let's look at some real world situations. A professional baseball should weigh 5.125 ounces with a tolerance, which means how much it can be off by, 0.125 ounces. Write an absolute value, or part A, write an absolute value inequality that describes the acceptable weights for a baseball. So we know the weight can't be off by more than this. So we want it to be off by less than that. So we know we're going to use a less than or equal to 0.125. We also know that we're writing an absolute value equation. And the ball should weigh 5.125 ounces. So I would take the weight of my ball and subtract 5.125. And if it's off by less than 0.125, we can keep the baseball. What would change in this if we wanted to reject the baseball? Well, it wouldn't be less than 0.125. It would have to be greater than 0.125. So all that changes is the inequality symbol. Example 6. A sleeping bag manufacturer suggests that one model is best suited for temperatures between 30 degrees and 60 degrees inclusive, which means we're including 30 degrees and 60 degrees. Write an absolute value inequality for this temperature range. So the first thing we need to do, and I'm going to help you think about this on a number line. Here's 30, here's 60. What's halfway between those? So we know 40's here, 50's here, but those quite aren't in the middle. The middle must be 45. So the middle is going to help us out. The other thing we need to know is how far each of these are from the middle. Well, they're both 15 away. So our middle temperature is what goes in the middle of our absolute value. So x minus 45 in our absolute value has to be less than or equal to, how far apart were they? 15. So this gave us in words and we turned it into a number line. What if they give you the number line and ask you for the absolute value inequality? We're going to use a similar idea. So right now our endpoints are on 4 and something over here. Well, it's halfway between negative 10 and negative 12, so it must be negative 11. We need to figure out where the middle is. So 2, 4, 6, 2, 4, 6. Now let's go a little bit more, maybe one more. Where would that be? It would be at negative 3.5. The best way to figure that out is, go back, from 11 to 4, this is 15 spaces. Half of 15, because we want halfway between them, is 7.5. If we want to go 7.5, let's go down from 4. So 2, 4, 6, then 1.5. That'll put us at negative 3.5 also. So similarly to how H worked in our standard form for graphing, this middle number is going to be the opposite of what it looks like. So we're going to add 3.5, and then it's going to have to be less than 7.5 because that's how much space it was from our endpoints to the middle. That's all for today. Fill in your summary, and I'll see you in class.